So 5.3, we're kind of going in a different direction from 5.1 and 5.2. We're going to be solving trig equations. So we're solving for x, and our goal when solving for x is to isolate the trig function. So we want to get that trig function all by itself. So looking at example 1, our goal is to get sine of x all by itself. So what should I do?
Add 1 to each side.
Add 1 to both sides. So I have 2 sine of x is equal to 1. What can I do next? Divide by 2. So sine of x is equal to 1/2. So when dealing with sine, we're looking at our y values. So we want to see where on our unit circle is y 1/2. So we go to our unit circle, and we have y is 1/2 here at pi over 6, and y is 1/2 here at 5 pi over 6. So our two answers here are x is equal to pi over 6 and 5 pi over 6. So this is pretty much what we're doing for all of these equations. The only thing is, which you'll see in example 2, how it gives us an interval, we're only dealing with the interval from 0 to 2 pi, so only one trip around the circle. Because when sine is 1/2, so when sine of x is 1/2, it's at pi over 6 and 5 pi over 6, but if I went around the unit circle more than once, I would reach it again at pi over 6 plus 2 pi. So if you were to, I guess, use math way for these questions, your answer would be pi over 6 plus 2 pi times n, because you can go around the unit circle infinitely amount of times. But we're just dealing with one trip around the unit circle, so we don't have to worry about that. So all of our intervals that we're going to look at is just 0 to 2 pi. So one trip around the unit circle. So sine of x tells us that we have to look at the y values. Cosine tells us that we have to look at the x values. And tangent is what? Y over x. You're welcome. All right, example 2. So remember, we want to isolate our trig function. So what should I do first here? I can subtract square root 2. And I want to add sine to the other side. So I have to combine my like terms, get those signs together. So what's sine plus sine? 2 sine. So I have 2 sine of x is equal to negative square root 2. What should I do next? Divide by 2. So sine of x is equal to negative square root 2 over 2. Now sine tells us we have to look at what values? The y values. So I'm looking at my unit circle. Where is y negative square root 2 over 2? 7 pi over 4, so here. And where else is y negative square root 2 over 2? 5 pi over 4. Be careful, because 3 pi over 4 is positive. So the signs matter. So it's 7 pi over 4 and 5 pi over 4. So here our answer is x equals, because we're solving for x, 5 pi over 4 and 7 pi over 4. So what should we do first for example 3? Add the 1. So just like before, we want to isolate our trig function. So we have 3 tangent squared x is equal to 1. What next? Divide by 3. So tangent squared x is equal to 1 over 3. And then what? Square root. So the square root cancels out with the squared. So tangent of x is equal to what? What are you missing? Plus or minus. So remember, anytime you take the square root of both sides, you need that plus or minus. So plus or minus the square root of 1 over 3, which you guys were a couple steps ahead. So you said this would be 1 over square root 3, so plus or minus still. Because if you take the square root of 1, that's just 1. And then we can rationalize, but it's good to know that this is the same thing as plus or minus square root 3 over 3. So this is just the rationalized version. Now we're dealing with tangent here. So tangent tells us we have to look at what values on our unit circle. Y over x. Now with tangent, it's a little bit different because our values on our unit circle aren't given to us as y over x. We have x and we have y that we can clearly see, but for y over x, we have to actually do some math. So I'm going to start with the first quadrant here, because if we notice, which after we do the first quadrant, I'll show you, that they start to repeat. So doing the first quadrant, y over x, so I'm looking for y over x. I have 1/2 over square root 3 over 2. I need to keep change flip. So this would be, the 2's cancel, so 1 over square root 3. Now if I rationalize my answer here, I would want to rationalize this, but if you leave it unrationalized, you can leave this unrationalized. So just be aware that these are the same thing. If you don't rationalize, then you want to look at the unrationalized one. Let's do the same thing for the next one. So I'm finding y over x, so this would be square root 2 over 2 over square root 2 over 2. I can keep change flip. What do I get here? 1. And then for the third one, I have y over x, so square root 3 over 2 over 1/2. Keep change flip. The 2's cancel, so this is just square root 3. Now we could do the math for every single one, but a good shortcut to know is that every tick mark here, so all of our special values that have the denominator of 6, so 6, 6, 6, and 6, they're all going to have the same 1 over square root 3, but the signs are different. So just be aware here, when you divide these, it'll be 1 over square root 3, but you have a negative and a positive, so this will be negative. For this one, you'll have 1 over square root 3, but you have 2 negatives, so it'll be positive. And then the 11 pi over 6, you have 1 negative and 1 positive, so it'll be negative, so 1 over square root 3.
So this could be all 4 solutions?
Right. I'm going to just, before we get to the answer to it, I'm going to show you the other ones too. So same thing for pi over 4. Everything that has the 4 in the denominator are all going to be the 1. So y over x is going to be 1. Here, y over x will be negative 1. Negative 1. This one, a negative divided by a negative, will be positive. This one will be negative 1 and 1. And then same thing, if it has a 3 in the denominator, those will all be the same value also. Just be careful with the signs. So this one's going to be negative square root 3. This one will be positive square root 3, and this one will be negative square root 3. So all you need to do is the math for the first one, and then just know that all the denominators go along with it. But just be careful with the signs. Here, we have to find where y over x is positive or negative 1 over square root 3. So at what radian measures is y over x positive or negative 1 over square root 3? What's the radian measure?
I thought you said what the coordinate.
So we see it here at pi over 6. Amber says also 7 pi over 6, which is true. But what about the negative 1 over square root 3's? What is it? 5 pi over 6 and 11 pi over 6. So our answers here are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Right, example 4 kind of gives us a hint that we're going to have to factor. So what should I do first? If I am factoring like just in algebra, what do I need in my equation to be able to factor? What does it have to be equal to? 0. If I'm factoring, it has to be equal to 0. So how do I get this to be equal to 0? Subtract 2 cotangent x. So I have cotangent times cosecant, or times cosine squared minus 2 cotangent is equal to 0. Now how can I factor? Do I have a greatest common factor? I have a cotangent in both of these, so I can take out a cotangent. So I'm dividing out a cotangent here. What am I left with when I divide out cotangent? Cosine squared minus 2. Because I divided a cotangent here and divided cotangent here to take it out. So now from here, I can set each one of these equal to 0. So I have cotangent of x is equal to 0, and cosine squared of x minus 2 is equal to 0. So in terms of x and y, what value do I need to look at when I have cotangent? X over y. If I'm looking for x over y is equal to 0, which value here, the x or y, has to be 0? The x has to be 0, because if 0 is on top, then your answer is 0. If 0 is on the bottom, then your answer would be undefined. So I'm looking for here when x is equal to 0 on my unit circle. So to solve, let's go to our unit circle. Where is x 0? You said pi over 2 and 3 pi over 2. So our two answers there are pi over 2 and 3 pi over 2. Yes, yes. So let's look at cosine squared now, or cosine squared minus 2. So what do I do first for cosine squared minus 2? Add 2. I need to isolate my variable just like I did before. So cosine squared is equal to 2. Then what should I do? Take the square root. So cosine of x is equal to plus or minus square root 2. Cosine tells me I have to look at what values? The x values. On my unit circle, do I have any x values that are positive or negative square root 2? Nope. So cosine of x here for this one is not on the unit circle. It's not that this is not a value. It's just we would need our calculator to solve for this. And the point of this section is to not use the calculator, just use the unit circle. So here, it's just not on the unit circle. And that would be our answer for that one. But we have x is equal to these two. So example 5, we are factoring here. What do I need to do? It already is equal to 0, so Yes. So we can see here that since we have sine squared minus a constant, that we're going to factor. So this is like saying 2x squared minus x minus 1 is equal to 0. This we know how to factor. How do I factor? What do I have to do first? Awesome. Multiply the first and the last. This would be negative 2. What are two factors of negative 2 that add to negative 1? Negative 2 and 1. So then here I would have x minus 2, x plus 1. And what do I have to do next? Awesome. Don't forget, since we started by multiplying, we have to go back in and divide. So this would be x minus 1 and 2x plus 1. So if it doesn't go in, we just move it to the front of that x. So since I replaced x into sine, I'm going to put sine back in here. So I have sine minus 1 and 2 sine plus 1. What should I do next? Set each one equal to 0. So sine of x minus 1 is equal to 0, and 2 sine of x plus 1 is equal to 0. So in the first one, I'm going to add 1 to both sides. So sine of x is equal to 1. And then the next one, I'm going to subtract 1 on both sides. So 2 sine of x is equal to negative 1, and divide by 2. So sine of x is equal to negative 1/2. So then I have to go to my unit circle. What value am I looking at for sine? The y values. So I'm looking at the y values on my unit circle. I have to see where is y 1. Pi over 2. Anywhere else?
Wait, why are we looking for a y?
The first one is 1. Nope, so just pi over 2. For the second one, again, it's sine, so we're finding y values. So now I need to see where is y negative 1/2.
11 pi over 6 and 7 pi over 6.
So 7 pi over 6 and 11 pi over 6. So 7 pi over 6 and 11 pi over 6. So these are 3 answers here. All right, example 6. So I have a trig function that's squared, and I have a trig function that's not squared. What should I do here? Lily?
You can make it so that the two trig functions are the same.
Awesome. So here we want to make our trig functions the same so then we can factor. So I have to change which one? I have to change sine squared x. So I'm going to use my trig identity. So I have sine squared plus cosine squared is equal to 1. I know I want to replace the sine squared x, so I need to get this to be sine squared is equal to, so I'm going to subtract cosine squared on both sides. So sine squared is 1 minus cosine squared. So I'm going to take this 1 minus cosine squared and plug it in to that sine squared spot. So I have 2 times 1 minus cosine squared plus 3 cosine minus 3 is equal to 0. We want to distribute. So I have to distribute that 2. So this is 2 minus 2 cosine squared x plus 3 cosine x minus 3 is equal to 0. Combine like terms. So I have 2 and negative 3. So negative 2 cosine squared x plus 3 cosine x. 2 minus 3 would be negative 1. So minus 1 is equal to 0. So I can make this negative 2x squared plus 3x minus 1 just to help us factor. And then what should I do? I can multiply the first and the last. So 2 times negative 2 times negative 1 would be positive 2. What are two factors of 2 that add to 3? 2 and 1. So here I have x plus 2, x plus 1. What do I have to do next? Divide by negative 2. Don't forget to divide by that number that you multiplied by. So here, this would be x minus 1. And then negative 2x plus 1. So then next, I can split it up and put my cosines back in. So I have cosine minus 1 is equal to 0. And negative 2 cosine plus 1 is equal to 0. Now we want to solve for cosine. So cosine of x is equal to 1. The next one, we need to subtract 1 on both sides. So negative 2 cosine of x is equal to negative 1. Divide by negative 2, so cosine of x is equal to 1/2. Now with cosine, I have to look at what values on my unit circle. X values. So I need to see where is x1. So on my unit circle, where is x1? 0. So x is equal to 0 is one solution. So that's the only one. Now let's look at where is y 1/2. So again, we're looking at y values here. So where is y 1/2? Oh no, we're looking at x. We're doing cosine. Duh. Okay, this should be x values.
It'd be at pi over 3.
So we have pi over 3. And where else? 5 pi over 3. So pi over 3 and 5 pi over 3. So these are our 3 answers. What makes example 8 different than the other ones?
Maybe there's not two different cosines to x value.
Santiago. There's a variable, but before we had a variable, it was just x. It's just one equation. But what's different in front of the x that we haven't seen before? It has a number in front. So this one has a number in front of the x. We solve it the same way, but our last step is just a little bit different. So we're going to do the same exact thing that we've been doing, but once we get to the last step, it's like one extra step, and then that's it. So, what should we do first? Add 1. So 2 cosine of 3x is equal to 1. Divide by 2. So cosine of 3x is equal to 1/2. Now the other class said, why don't you just divide the 3? We can't divide the 3 because it's in the cosine. So my trig function is isolated. So now I can look at the unit circle. So what value am I looking at the unit circle here when I'm dealing with cosine? The x values. So I'm looking, where is my x value? 1/2. Pi over 3, and where else? 5 pi over 3. So my x value is 1/2 at pi over 3 and 5 pi over 3. But the only difference here is that I have this 3x. So instead of just saying x is equal to and then I'm done, I have 3x is equal to this and 3x is equal to this. Not yet. Still have to solve for x. So last step, what do I need to do to get x all by itself? Divide by 3. So this is the one additional thing that we have to do. Just divide by 3. So keep change flip. So this would be 1 over 3, so we would make this pi over 9. And then do the same thing with the other one. Divide by 3. Keep change flip. So 5 pi over 9. And these are our two answers.